Welcome to The Explainer. All right, let's just dive right in. Today, we're going to talk about two of the biggest and honestly kind of hidden challenges that artificial intelligence is facing right now. We're talking about its shaky relationship with the truth and its absolutely massive appetite for energy.
You've been there, right? We all have. You ask an AI a totally straightforward question, and it gives you back this answer that sounds so confident, so plausible, and it's just completely, utterly wrong. I mean, look at this. The AI was asked to name politicians born in New York City. Now, it gets Donald Trump right, sure, but then it goes ahead and confidently throws Hillary Clinton and Michael Bloomberg on the list. The only problem? Yeah, Clinton was born in Chicago and Bloomberg's from Boston. Not even close. So this isn't just a simple mistake. It actually has a name in the AI world. They call it a hallucination. It's basically when the model just makes stuff up. And you can imagine this is one of the single biggest roadblocks to us actually being able to trust these incredibly powerful tools. And here's the thing, this whole truth problem, the wrong answers that we can all see, it's really just the tip of the iceberg. It's tied to a much, much bigger challenge that's happening completely behind the scenes. So what are we looking at? 29.3 terawatt hours? That is the estimated amount of energy that generative AI models use every single year. And just to put that number in perspective for you, that's more electricity than entire countries like Ireland or Sweden use in a whole year. It's staggering. Okay, so we've got two huge problems on our hands. One of trust and one of energy. Where do we even start to fix this? Well, in this first part, let's tackle that trust issue head on and look at a really clever way to teach an AI how to be more truthful. You know, the big idea here is actually brilliantly simple. What if, instead of just spitting out the very first answer it thinks of, an AI could be taught to just pause for a second, think about it, and actually check its own facts before giving you the final answer? Well, researchers have figured out a way to do exactly that. It's a method called chain of verification, or COVI for short. And the best way to think about it is like installing a tiny little fact checker right inside the AI's own brain. And this breaks down how it works perfectly. It's like a four-step dance. First, the AI drafts an answer, its first guess. Second, it plans how to check that answer by making a list of questions about it. Third, it actually goes and answers its own questions. And finally, it uses all that new info to generate a final and hopefully much more accurate response. So let's circle back to our politician example. On the left, there's that first wrong answer. But using COVI, the AI would then basically ask itself, hang on a second, where was Hillary Clinton actually born? And as you can see on the right, it finds the correct answer, Chicago. It does the same thing for Bloomberg, realizes its own mistakes, and then takes them off the final list. So here's the million-dollar question. Does this thing actually work? Well, the data says, oh yeah, absolutely. This table shows a key metric for accuracy called FACT score. A standard model scores around a 56. But when you switch on COVI, that same model jumps all the way up to over 71. That is a massive 28% jump in truthfulness. It just works. All right, now let's switch gears and talk about that second invisible problem. We've seen a pretty brilliant fix for the truth issue, but what about that mind-boggling energy cost? In this next part, we're going to dig into the hidden price we're paying for every single AI query. To put it bluntly, the way we're doing things now just isn't sustainable. This brute force approach of just building bigger, and more powerful models is causing this explosion in energy demand. And that's creating a huge challenge, both for the environment and just for operating these things. So what's the answer? Well, it's not just about more raw power. It's about much smarter engineering. And this is where a new design philosophy called the multi-agent system improvement, or MASI architecture, comes in. Its whole purpose in life is to eliminate waste. So how does an architecture like MASI actually make AI smarter and greener? In this third part, we'll see that it's less like building a more powerful engine and a lot more like building a super intelligent traffic control system for all the AI's internal processes. So MESI is really built on three key ideas. First, dynamic orchestration. That just means using the right tool for the job. You use a small, efficient AI for a simple task instead of a giant energy-guzzling one. Then there's shared state management, which gives the AI a memory so it doesn't have to refigure out stuff it already knows. And finally, governance acts like a supervisor, stopping it from getting stuck in these expensive, time-wasting loops. And this quote right here, it gets to the absolute heart of the problem that MASI solves. See, inefficient systems suffer from what you could call AI amnesia. The AI agent literally forgets the context from 1 second to the next. That forces it to constantly go back and reread and replan everything, and that just burns through a ridiculous amount of energy. And the effect of fixing this, it is just staggering. By building systems with smart design principles like MASI, you can cut down the number of tokens, those are just the little bits of data an AI processes, by up to 9 times. Think about that. That's doing the exact same amount of work with nearly 90% less effort. And all that efficiency with tokens, it translates directly into real-world energy savings. Just look at the table. For every million tokens that an old, inefficient system would process, a really well-optimized MASI system saves almost 6 kilowatt-hours of electricity. That is a real, measurable impact on sustainability. And this really brings us to the core takeaway from this whole thing. We are at a crossroads with AI development. One path is just brute force, build bigger, more power-hungry models and hope for the best. The other path is smart engineering, building systems that are self-correcting, super efficient, and can adapt on the fly. So, what does this all mean for the future? In our final part, let's pull these two big ideas together, truth and energy, and really look at what the future of AI engineering is starting to look like. You know, the next huge breakthrough in AI probably won't be some model that can write a slightly better poem. It's going to be the engineering that makes AI trustworthy enough and sustainable enough to really become a part of our world. We're shifting from asking, can it work, to how well does it work? Solving for truth with tools like Covey and solving for energy with designs like Mossy, these are two giant leaps in the right direction. And it really brings us to a final, critical question about the future of AI. We know for a fact it's getting more powerful, but is it actually getting smarter? So we've uncovered these huge, invisible problems of hallucination and energy waste. But as we start to solve them, it kind of makes you wonder, what's the next big challenge that's waiting just under the surface? And what new ingenious solutions are we going to have to invent to truly master this technology?